Welcome back, learners, to Lesson 16, Session 1. You were working on the independent practice on pages 339 and 340. Now, on this page, remember, if there are things that you have that are incorrect or you're missing some information, you're welcome to go ahead and write it in because that's the best way that we learn. So if you need to, pause your video and we'll go over the answers. Now, in this number 1, you were showing me everything you knew about area and combined rectangles. Now, combined means put together. So what do we know about putting some of our rectangles together? Now, first of all, what is a combined rectangle? It is a rectangle that is made up of 2 or more rectangles. I remember learning a word about made up of, right? Didn't we learn something? Oh, that's right. I want to use that big word because you know what? We want to sound like really intelligent third graders. Remember, made of means composed. So if we want to sound really intelligent, we're going to take that word right there. Remember, that means composed because we're going to talk about this word later on. And I want to make sure we use it. A rectangle that is composed of 2 or more rectangles. Okay, what do we know about combined rectangles? Well, I kind of wrote down what I know, and if you want to add to it, or maybe you have a better answer, and I wish I could hear from you guys. Okay, what do we know about combined rectangles? I can add the areas of each smaller rectangle to find the total area of the combined rectangle. That's what we did with all those pictures. We found the areas of the smaller ones, and we added them to find the combined rectangle. So then they wanted us to draw some examples. So there's different ways, and your pictures could be different than mine, and they're still right, as long as you show separate rectangles that become one rectangle. So I could have 2 completely separate rectangles that I pushed together, kind of like we did the posters for the classroom wall. Or you can have a large rectangle that's been split into 2. Or you could have a rectangle that's been split into 3. And notice they don't all have to be the same size. They can be different sizes. Okay, now let's look at number 2. They have 2 rectangles. It asks, did Lola and Eric each create a combined rectangle from rectangles A and B below? Explain. So they both took our rectangle A and rectangle B and they put them together. Let's look at how they did that. I'm going to zoom in a little bit. It might help us. Okay, so Lola took rectangle A and notice that rectangle B also has a width of 3. So what Lola did is she just took the 2 of them and she pushed them together, which is what we did with the posters on the classroom wall. So did Lola do that correctly? She did, because the 3 inches is the same width as the 3 inches. She just scooched it on over there. So yeah, she did do it right. Now Eric did something different. What did Eric do? He actually moved it. So Lola just pushed it over there. Eric, he took it and he moved it down and he rotated it and then he moved it over. So he did a very different method, but do you know why he was able to do that? He was able to do that because the width is 3 and the length is 3. Since they're both 3, he can take that and he can shift it and rotate it and push it on the bottom. So he did it correctly too. Now, if we want to double check, we could actually mathematically make sure this is right. Lola's, remember, area is length times width. We always want to check our work, right? The length is 4. The width is 3. 4 times 12. Now, let's look at Eric's. Eric's length times width. What is his length? It's only 3 because remember he moved it. And then the width is, oh, notice the 4. 3 times 4 is 12. Are they both 12? Yes. Lola and Eric did it correctly. What do you notice about these? That is a special property we talked about before. Remember, this is what we call commutative property. because this is multiplication, we can actually move our numbers. We can move their location and they still mean the same thing. 4 times 3 is the same thing as 3 times 4. Remember, commutative means to commute. Commute means to move from one place to another. I've moved my 4 to the end and my 3 to the beginning, and it's still 12. Okay, let's look at number 3. Now, in this problem, I had to do some drawing. And remember, there's going to be 2 different ways that you can solve this. Now, remember, I'm going to always show you both ways. You don't have to have both ways, but I want to make sure that you understand that if you didn't use my one method, you could have used the other method. So as long as you get to the right answer and it works for you every time, then that's awesome. Okay, so Kelsey, this was Kelsey's mat, right? And we have Greg's mat. Now, Kelsey's mat is larger than Greg's. And what we did in one way, if you want to use the additive method, you can add Kelsey's mat to Greg's mat. Now, notice that Kelsey's mat is 4 and has a length of 4 and a width of 3. So 4 times 3 is 12. That's how I got Kelsey's area. Greg's mat is 3 by 2. Notice it's a 3 by 2. And so 3 times 2 is 6. Now, just like we did in our practice, if you take Kelsey's mat and you add Greg's mat, you get the total area. So 12 plus 6 is 18 square feet. This is the additive part. I can add Kelsey's area plus Greg's area to find the total area. Now, it's possible that you might have done a combined rectangle. Now, the combined rectangle, you could do what we did on this side. So remember how Eric took the rectangle and he pushed it down, he rotated it and moved it over? You can do the same thing here for Kelsey and Greg. So notice what is going on here. I'm actually just going to sketch Kelsey's really quick. Right? So let's go ahead and sketch Kelsey's. Notice it's 4 and then 3. Now what you can do with Greg's is notice that since this is 3 and this is 3, I can actually make those 2 areas touch. So I'm going to take Greg's and I'm going to turn it. So now I'm going to show you like I turned it. Oops, I drew it a little too long. Okay. So do you notice I took Greg's and I rotated it, right? I turned it. Now we would just scooch them together. And so if this one's 4 and this one's 2, I now have a total side 1, 2, 3, 4, 5, 6. So I now have a length of 6. And my width is still 1, 2, 3. Notice that? It's still 3. So a length of 6 and a width of 3. 6 times 3 is 18. Notice I have 18 square feet and 18 square feet. There are 2 ways to do this one. What method did you use? Did you use the additive method or did you use the combined rectangle method? Both of them work. Now, if you don't have either one, I want you to think about which one you like the best, because you know what? You get to use the one that you want on the future problems that we do. If you like additive, you can do additive. If you like the combined rectangle, you can do that. Think about which one you like. And let's go ahead. That's the end of today. I'll see you for session 2.